23 AP Stats Early Solution Mock Scoring Guide. Okay, so the first question, I'm going to go to the question itself. You can read it if you'd like, but basically what you're supposed to do is describe the histogram, and the histogram for A is basically cuss and BS. So center is going to be the median between 11 and 12 milligrams per liter. There's not any unusual features. Shape, so the first one's the center shape is that it's going to be skewed to the left. The spread, you can talk about the range, that it's somewhere between 10 and 12, or you could talk about the IQR. And a possible outlier is between 2 and 3 milligrams. And then you're going to talk about the context, that it's dissolved oxygen concentration in streams. Okay, so for the scoring for A is that the first part you'll get an E if you had all 5 of those descriptions of the histogram that I talked about: the median, the outlier, the shape, the spread, and the context. If you had 3 or 4 of those, score yourself a P. Okay, for the second one, it gave you this description here, and it asked you to find a box plot of this data. So to do that, you would just draw the box plot. It told you to ignore the outliers. So I got the scoring here. You get an E if you got the box plot as drawn. If you made one mistake, possibly the outlier or something, I scored it as a P. Okay, for letter C, basically it's asking which one has higher dissolved oxygen concentration as far as healthier wildlife. Would it be the box plot that you drew or the histogram that was given? And which one is that? Which was the histogram was the colder and the box plot was the warmer. And this is the answer that I got. That number 1, that the streams with colder temperatures were generally healthier. Number 2, because some sort of a data, like for instance, you could say the median in the streams less than 8 degrees is between 11 and 12, which is greater than the median of 5.43 of streams that are warmer than 8 degrees. You could also talk about the next part, which is one or the other is what's necessary for the point. 75% of the streams with temperatures warmer than 8 degrees are less than 6.12 milligrams per liter, but in streams with temperatures colder than 8 degrees, it is about 93.6% are greater than 6.12. So you could, any 2 things that are going to be comparing them that are going to show your proof that the streams and the water temperature are colder are generally healthier. So that's the second point. And the third point is just go ahead and put in the context in this problem. So I have an E as all 3 components and a P as 2 of those 3 components. The scoring is below, which you need all E's to be able to get a 4, the 3, 2, and 1. And I did not put the I's here. That's just assumed if it's less than the P, it's going to be an I. All right, so for the next one, number 2, the problem here is about the driveways adding fibers. You can read the question if you want to remember it. And the first question is asking what's the experimental units, treatments, and response variables. So let's go ahead and look at A. So for A, the experimental units are 60 new homes that needed driveways. I believe it would be accepted if you said 60 driveways. Treatments would be, but you have to make sure you have the 60 for sure to be able to get the credit at all for that. Treatments, concrete that contains fibers and concrete that has no fibers. You need to list both of those to get the point for treatment. And response variables, severity of the cracks on a scale. If you didn't put 1 to 10, I think that would be fine in order to get the point for the response variable, but you do need to mention that it is on a scale. As far as scoring that part A, all 3 descriptions of the 3 things that we just talked about, the treatments, the response variables, etc., need to be correct in detail to get the E. If you got 2 of those correct, I believe that would be a P. And again, there they are. Okay, so for part B, it says describe an appropriate method the developer needs to use to randomly assign concretes that contain fibers and concrete that does not to 60 driveways. So the answer is the first basically thing you need to do is you need to number them in some sort of aspect, whether you number them on index cards or just say you're going to number them or some sort of numbering system. That's the first thing, has to be numbered from 1 to 60. Secondly, you need to describe the random process. You cannot just say randomly assign or randomly this. You have to say use a random generator, put them in a hat and shake them up. Anything that describes the random process is the component 2. The third thing is you need to make sure, because the problem originally did ask you to get 30 unique numbers, 30 in 2 groups, that you need to make sure that those processes end up with 30 groups in each one. For instance, if you rolled a dice, if you flipped a coin 60 times, you're not necessarily going to get 30 and 30. So you need to make sure whatever your method is that it does come up with 30 driveways in each one. So the scoring, because you can, the scoring here, if you had all 3 of those components that I spoke about, as far as numbering, a random process, and making sure they're all 30, part B has all 3 components as the E. If you had 2 of those 3 components, that's a P. Less than would be an I. All right, so for this next part here, suppose the developer finds we have statistical significant reduction, and then it says in the conclusion, what's the benefit of randomly assigning? So remember, random assignment creates roughly equivalent groups, so that which means that it reduces bias. And so you have unbiased groups, which means basically the same group. So you could have said that in either way. That's the first component. The second component is just to say the only difference between the groups is that the one group has concrete with fiber, the other one does not. And then the third component you're going to say is that because you have random assignment, it allows the developer to conclude cause and effect, that which driveways have a reduction in the severity of cracks because of the fibers or no fibers. So those are the 3 components. Same sort of scoring for the last one. All 3 components gets the E, and 2 of the 3 components gets the P, and less than that is an I. Same scoring as number 1 with the E, P's, and I's. All right, so for the next problem, number 3. Number 3 is the bath fizzies, and the first step what you had to do is 1A, is that you had to calculate this probability right here, which was blank, and to do so you just had to subtract the sum of these probabilities from 1. And then the second part, it says what's the probability that it contains at least $10, and for that you just had to add up all of these probabilities, and that would be the total probability. So let me go ahead and show you the work. Okay, so for the first one you see is 0.68 and the second one is 0.12. You'll see the scoring on this one is a little bit different because we have 3 parts. Oh, you can't really see it from here. Let me show you how it goes in. Yeah. So it should see the bath fizzies. You can see it's not showing as well. I've got mine a little bit off here, but you can see both 1 and 2 are correct with work, and the P is 1 or 2 is correct with work, which is the probabilities of both of them. Okay, so part B asks you to go ahead and find what's the probability that the bath fizzy is going to contain $100 given that it's more than 10. So that's going to be 0.01 over 0.12, which is 0.083. And I'll show you where that came from. It's just this here. I'm saying what's the probability that this one here is going to be chosen out of these 4. So that's where the 1% over the 5 plus 5 plus 1 plus 1 came from. And the scoring on this one is actually kind of interesting because if you had it correct with work, you get the E, but you get a P if you have no work or you got the numerator correct or the denominator correct. So let's visit that again to look at what the numerator is and what the denominator is. So if you got the 0.01, which was the 100 on the numerator, you got a P. If you got the 0.12, which is the denominator, you also got a P. Obviously, if you got both of them, that's an E. But if you only got one of those, that's at least a P. Okay, the next question did ask you to find the expected value and then to interpret it. So the expected value is just you're adding all of the probabilities times their values up to get $4.68. And then if you have many bath fizzies, we're open on average amount, the price is going to be about $4.68 in the long run. So the scoring on this one is going to be for part C, you calculated the expected value and correct interpretation is E, and then if you just did the expected value or just interpretation, that would be a P. The last problem asks you to just convert it to euros. Here's the original problem, and it says a dollar is 0.89 euros, so go ahead and convert it. And to that one, you just take $4.68 and times 0.89 euros, and you get 4.1652 euros. And that one, just correct with work for the E and correct but no work would be the P. For this one, because there's 4 parts, A, B, C, and D, each E is a point and each P is a half a point. When you come up with the total score, you have to round down. You only can have a whole number for any of these scorings. You can only have a 1, 2, 3, 4, or a 0. So if you end up with a 2.5, it is going to be a 2. Make sure you round down for your scoring. Okay, for the next one here is number 4. Let's check it out. It's the omega-3. This one here wanted you to run a paired t-test. So it gave you this data here. It gave you the numbers, it gave you the graphs, and then it asks you if it's statistically significant, if it's greater than. So you're going to go ahead, let me show you the answers, the solutions, and then we'll talk about how it's going to be broken down. Okay, I put it in an A, B, C, D form, but it's really part 1, part 2, part 3, part 4 form, but that's okay. So let's just kind of go through here. I'll talk through it, and then we'll go ahead and I'll show you how the scoring is. First of all, the HO is the mu D is going to be equal to 0. HA is mu D is greater than 0. And mu D is defined as the true mean difference of irritability scores, placebo minus omega-3 for all patients with a medical condition similar to the volunteers in the study. So for the scoring on this one, if you had the correct HO and HA and the mu D, that's an E. If you had the correct HO and HA or the correct mu D, but not both of them, that would be a P. Okay, the next scoring part is going to be part 2, which is you're going to identify it as a match paired t-test. That would be the correct with a degree of freedom, which I think I left on my scoring, but I'll bring it back, with a degree of freedom of 18. And then the conditions of random, assignment. If you said random sample, you would not get it correct because these are random assignments. Normal model or large sample, the box plot of differences shows no strong skewness or outliers. Basically, you're saying, hey, n is equal to 19, so it's not greater than 30, so I can't use a central limit theorem, so I have to look at them and I can see that it's no strong skewness or outliers, so therefore I can conclude it's approximately normal, which would be the conditions. So let's go ahead back to here and see. Yes, you named the test, degrees of freedom, and the 2 conditions are checked correctly. That's your E, the ones we just talked about. If you have 2 or 3 of those 4 components, you could receive a P. All right, so for component 3, or part 3, I guess, I believe that you would be required to identify XD, which is 1.789, SD, which is 2.485, and N, which is 19, T, which is 3.14. Now, you could put it in this formula the way that it is shown here, just like this. You do not need that part there, but this part here is fine. Or you could have them all listed out from your calculator. Either way, I believe those are the 4 that you need, and the scoring would be as such. So you need all of those, the ones I just listed, X bar, SD, N, and T, to be correct, labeled, or in a formula. If you only had 2 or 3 of those particular ones correct, that would be a P. And the last part, I believe that said, first of all, I found my p-value. Then I rejected HO, because I linked the p-value to the HO, where I said because it's low, we reject HO, and there is convincing evidence. So you have to have, 1, the p-value, 2, the connection of between the p-value and 0.05, and then I'm rejecting HO, and there's convincing evidence, and then I've got my context in the study. So we have my p-value, reject HO because of the alpha, evidence for HA, context. If you had 2 or 3 of those 4, we're going to give you a P. Again, this was a 4-part question, so it's 1 point for an E and half a point for a P. And you're going to round down again if you have anything like 3.5, 2.5, 1.5, or 0.5. Okay, the next one is the tool elk. That's also a 4-part question. So let's go to this one here. Yes. So here is a line. Basically, you can read the question if you'd like, but it is a linear regression. And I ask, part A says, describe the relationship between chest circumference and weight of the male tool elk in context. So 4 components is going to be the E, and 3 of the 4 is going to be a P. And let me go ahead and describe it for you. It's going to be strong. That's a component. Positive. Or strong, you could call it moderately strong. You can't call it moderate because it's the pattern's too tight. You can call it moderately strong or strong. Positive is an S aspect, linear, and then relationship between chest circumference and weight would be the four components. As I stated, that the four components would be the E. If you had three of those four components, that would be a P. The next one, if you got number 1 right, which is plugging 1.4, oh, excuse me, let me go through and help you show you what that question is. The next question says, okay, here is the linear regression. I gave it to you, predicted weight right here. And then it says using, but here is actual, this is an actual measurement, 145.9 centimeters, and you get 204.3 kilograms. Using the least squared regression line, it wanted the predicted weight, and then it wanted, for part 2, they calculated the residual for the male. So if you're going to do so, the first thing you needed to do is plug in 145.9 to get 196.17 kilograms. The residual, actual minus predicted, gets you the 8.13 kilograms. So if you had both of those work and answer correct for both part 1 and 2, you got your E. And a P would be just 1 or 2 if it was correct with work. All right, so part C, your predicted weight is here, and you interpret the slope of the least squared regression line in context. And you have, for every increase of 1, that's a component, centimeter chest circumference, the predicted, that's another predicted weight, that's another component. For male, Elks increases, that's another component, and then, male, which is the context, and then increases by 3.7455 is the fourth component. So 1 centimeter chest circumference is the first one, predicted weight is the next, and then male tool Elks is the next one, increases by 3.7455. And that one is the same aspect. All 4 components of those would be the E, and 2 or 3 of those would get you a P. All right, so for part D, if you had both of these correct, you get the E. If you had one of them correct, we're going to call it a P. So let's look at the question. So this question here says, basically, you can read the question, and then it gives you ho, and it gives you ha. It says, hey, the slope is equal to 4.5. The slope is not equal to 4.5, so that is two-sided. It gives you a test statistic of 3.408. So you can use a TCDF on both sides to be able to find that p-value. So if you use a TCDF, you will get to 0.001 on each side. You have to double it to get 0.002. And then for the second one, you have to, assuming ho is true, where there's a 0.002 probability of getting an obtained sample or more extreme in either direction purely by chance. And because obviously 0.002 is less than 0.05, we reject ho and do not have convincing evidence that the slope of the population, the regression line, is different. So if you had 1 correct and 2 correct, give yourself an E for that question. If you just had one of them correct, then you get the P. Okay, so now go ahead and let's go ahead and take a pause here. We're going to do the subtotal for the FRQ points. What I'd like you to do is you're going to multiply 1.875 times the total points that you have thus far. Add up all the points 1 through 5 and multiply it by 1.875. Okay, and put that number aside. Okay, the next part here then we're going to do is we're going to go to number 6. So number 6 is, the question was about Cleo. And Cleo's, if you didn't get this last one, I apologize. For number 5, that's what the question was. Okay, so for number 6, Cleo has necklaces that she has, and her average weight of her necklaces that she has in this store is 300 milligrams and standard deviation of 5. What's the probability of obtaining a necklace size between 296 and 304? So first of all, let's see what the solution is. So the solution is just a normal model. It tells you it's normal. So 300. So for this, you would need to make sure that component 1, you have the bounds, which is 296 and 304, either in a drawing or written as lower bound, upper bound. You have the mean as 300. The standard deviation is 5, again, in the drawing or labeled. You need to then, at the 4th component, find the actual area, which is about 58%. Okay, so for this one here, all 4 of those components is going to receive, you'll receive an E. You need 3 of the 4 components to be able to receive a P on that question. For part 2, now Cleo, letter B has 2 parts. So now Cleo has 2 necklaces, and it's the same mean and the same standard deviation, except now I have a sampling distribution of size 2. So the only thing that's going to change is my standard deviation, which is going to be 5 over square root of 2, since I have a sampling distribution of size 2. So if you notice this, the model looks very similar, mean of 300. Except the standard deviation is now 5 over square root of 2. So for this, you would need, for 1, you would need the mean, you would need the standard deviation, you would need the bound of 303, and you'd need the area of 0.1977. So, but part 2 then continues and says, well, what happens, what's with this particular thing you just found, with this result, indicate that the machine is different. Well, different would mean I would have a ho and a ha as a not equal to, which would mean it's called a two-sided test, which would then I would have to multiply my 0.1977 times 2 to get it a two-sided test. And this is why I say no, assuming it's working properly, there's a 39.54% probability that of getting a sample mean of 303 or more extreme in either direction purely by chance. Then you're going to connect it and say, but 39.54% is much greater than 5%, so we do not have convincing evidence that the mean gold amount is different from 300. If you got the first part right, that would be an E. If you got the second part, or excuse me, first and second part right, that would be an E. If you just got 1 but not 2, or 2 but not 1, that would be a P. All right, for this next question, this was an interesting question because it just said, okay, here's a graph with a sigma standard deviation of 5, 8, and then 12, and it just asks you, okay, I want you to basically cuss and BS for graph 1. And here's graph 1 here. Here's the cuss and BS here. And let's go ahead and look at a cuss and BS. So you would say the sample range of a random size sample is n equals 2 for normal distribution, because that's what it told us already, with a standard deviation of 5 is skewed to the right. Number 1, skewed to the right. Number 2, standard deviation is equal to 5, because it already told that. Median is about between 4 and 5, and range is about 28. You could have done IQR if you wanted instead of range, and then you don't have to mention the outliers, but you could if you wanted to. And then number 2, as the population standard deviation increases, the graph becomes more skewed to the right. You could say the medians get further and the ranges get larger. I think that it would accept more skewed to the right, or ranges increase as well. So for this one, I have scored, which I'm not really sure that's actually being, basically I said if you got both of them correct, we're going to give you an E. If you got one or the other correct, that's going to be a P. I think actually when it actually comes to scoring, they're going to mix it up a little bit more, but for mock score sake, we'll just go with this. And the last one for part D, it says, the first thing it says, okay, what's the probability with the standard deviation of 5 that you get a range of 10 or more? So you had to go back to this graph, and basically you're going to say, okay, 10 is here, and that's 4%. And then this one here, anything 10 or more. So all of these, we're going to look at the probabilities, and let me show you the math behind that. So the math behind that is, you see that first one's 4%, and then 3%, so forth and so on and so on. It adds up to 17%. So therefore, I can say there's about a 17% chance of getting a sample range of 10 or higher purely by chance, but this is greater than 0.05, so that is not unusual. And then the last question is interesting, and it says, and this is, I think, the trickiest one on there, and it says, do the sample means of 303 milligrams and range of 10 milligrams indicate the machine is not working properly? Notice it says and so and it's means that I'm going to multiply because they're two independent probabilities, and so that's working back way back here to this answer and then also to this answer. So let me show you, because you can see the probability of getting greater than 303 given 300 was 39.54%. Remember, that came from this one. And then the next one was the one we just found in the previous problem of 17%. Because they're independent probabilities, you can multiply them together to 0.067. But guess what? That's still greater than 0.05. And so because 0.06 is greater than 0.05, we do not have convincing statistical evidence that the machine is not working properly. All right, that completes the scoring. Again, both of those correct would be an E, and one correct would be a P. Same thing here. 1 point is an E, and half a point is a P. Make sure you round down. All right, and so the final scoring is going to be the total points. Recall that you've already have the points for number 1 through 5 times 1.875. That's the subtotal. Now you're going to take the points for number 6 and multiply them by 3.125 and add those together, and that's your FRQ score. Remind you that the MC is out of, there's 40 MCs, and you're going to multiply those by 1.25, and that would also get you the scoring. We don't have the cut score yet as far as what's a 5, 4, 3, 2, and 1 yet on this scoring. My anticipation is that a 5 would probably be somewhere close to a 70, 4 would be somewhere close to a 58, and 3 would probably somewhere close to about a 45. Those are my guesses, and I hope this helped. All right, thanks. Have a great night.